What's up, everybody, and welcome to today's video. In today's video, we are in sunny Arizona at Machinewise's HQ, and we're going to be taking a look at how they actually manufacture their products. Now, if you thought making balisongs was in any way simple or easy, do I have news for you? Because this is such an incredible and complex process that they have going on here. The level of detail that they put into each one of their products is utterly insane, and we're gonna go through each one of the steps of their process right now. But unfortunately, before we actually get to that process, we're gonna have to overcome the jail door situation that has been laid before us out here. So let's figure that out.
But before we figure that out, are you tired of paying full price for Machinewise products, even though they're so good and we've loved this stuff for years because oh my god? Using the link in the description, you can get a substantial discount on all of Machinewise's products. Using the link gives you a discount and us a kickback, which is a massive help, especially when we're making these huge videos. So if you want to support Machinewise, your poor little wallet, and us at the same time, consider using the link in the description, which automatically applies a discount code at checkout. Machinewise.willhirsch.gay. Thank you for using the code. Now back to jail.
So let's see if we can get in. Let me in! Let me in! Oh, hi, Dalen.
Hello, would you like into my jail cell?
Yeah, I would love if you would Shawshank me right in there. I won't take the machines this yet.
That wouldn't be very machine-wise of you.
Oh, Brandon, that hurt my soul. Thank you. Please?
Yes.
Yes.
Yes. Welcome to jail.
Wow, this is quite the, oh, it's so secure.
Not very.
Wow, okay. So, we like to jest a little bit, but we've actually been here for a couple days now, and this is a little bit smaller than the Squid Industries facility.
Correct.
This is basically one large room, right?
It is literally one large room.
Last time that we did a factory tour, we got to visit Squid Industries and see what at the time was their massive facility, which I've heard has gotten massiver. This will be a bit of a different take because we've got a much lower key operation here that I think you'll find very interesting, because for me at least, it was a little bit more relatable what was going on here than the very large operation in Squid.
So this room here is assembly and shipping.
Okay, so this is the end of the process.
This is the end, yes.
Okay,
so everything kind of starts in the back there.
Well, I guess we better make our way back there.
Hi, Jacob.
Hi, toilet. Okay, what do we got here?
Yeah, so this is where everything basically starts. This is all of our raw material.
So this is the same as at Squid Industries, they had the area where they were cutting everything.
Correct, yes.
Gotcha.
Yep. We do something a little bit different where we have all of our raw material bandsaw cut to our dimensions first for our fixtures. So this is material for like serif and opus handles, so our titanium sandwich material.
So this is just a bar of titanium that will then be refined later.
Yes, exactly, yeah. It's raw material. It's just been bandsaw cut so we can use it easier. This over here is the channel material for like SlifT tees. And so we keep all of our like Prisma handle stock is all down here in the drawer. Oh yes.
Yeah.
This will last us maybe a month or so.
This is only a month. I see the brass here. Is that for the weights?
It is, yeah. So we do have to bandsaw two specific items. One of them is our blade stock. They come in 3-foot-long bars right now.
Got it.
And we are actively working on having all of them laser cut and more ready for us. So this would be like a just raw blank for like a serif blade. The less time that we have to spend prepping our stock means more time that we can have the machines running.
Yeah. So having it pre-cut, I'm sure, especially at your scale,
is nice.
Very convenient.
Yes, like we are a small shop, but our volume is very high for the size that we are. Before they go over on the machines to turn into real blades, they have to be heat treated. We do all of our blade machining in the hardened state. It's the most accurate and we get nice shiny finishes. So it'll go from this, it'll actually go right over here into our heat treat area. This one here is our heat treat kiln. It gets up to 2,050 degrees Celsius.
Oh wow, that's hot.
Up to 2,050 degrees Fahrenheit.
Oh my God, that's hot.
We will take just this raw blank blade and they'll go into one of these foil bags. Hot material will oxidize and it'll create scale around it. So we put them in this bag to keep it safe from the oxygen so they'll come out nice and clean and not oxidized or have any scale on it. They'll sit in there for about 30 minutes getting up to temperature. Then we'll pull them out and we'll do what's called plate quenching. And so like on a regular carbon steel, you know, you get it hot, dip it in oil to quench it. For the stainless material, you actually need to plate quench it between 2 aluminum plates.
Oh, so that's what these plates are.
They suck the heat out of it, and that's the actual hardening, quenching process. It also helps us keep them flat as well. These are machined flat.
That makes sense,
And yeah, this will help keep them flat before surface grind, which the surface grind then makes them perfectly flat and parallel and to the right thickness, so then they look like that before they get machined.
So this is a finished surface ground,
That's heat-treated, surface ground, blade blank. They're now ready to be machined.
Okay, so the blade blanks are created and then they're
Yes.
heat treated.
Yes.
Other than that, the other materials you have going on here, I've noticed, how much does the bar of brass weigh? I don't think I've ever listed a solid brass.
So this is actually half the length of what it would normally be. They come in 8-foot sticks, I believe.
Oh my God.
So we cut them into 4-foot sticks. So I'd say this is maybe 6-7 pounds.
Oh my God. Yeah, that's a lot denser than it looks.
Yeah, brass is a pretty heavy material.
Oh my God, that is very obviously not steel.
Basically, all of the material will get prepped in the machine right over there.
All right, so we bring our raw stock over to here.
Yes, so from here, these will get loaded into the machine on the vise in there, and they'll basically just go from this, it's oversized on this thickness. They just get faced down like that, and then they also machine the end to the right length. So,
Okay, so you're getting all of that in one go.
yeah, exactly. And so we're taking off about, that much material. That way it'll just fit into our fixtures properly.
Understood. Do you
Yep.
face both sides of it?
No, just one. The less operations you have to do, the faster parts can get made, so we don't want to have to flip it over and do it again.
From that point, where do you go? Does it stay in the same machine? Does it move somewhere else?
Right, so it depends on what the material is. So like if it's aluminum, these will end up going into the Prisma fixture, which this machine does run and is running right now.
Okay.
It's actually doing a tool change. Oh, it just finished.
Oh, good job, buddy.
How fortuitous.
How fortuitous.
So
It's
these,
almost like we planned it,
yeah, right.
but we literally didn't.
No, we did not. So these would get loaded up into this Prisma pallet right here.
Does this pallet contain both parts of the process? Because I remember at Squid Industries, we talked about how they would load in the raw material,
Yep.
and then you have to flip it over and do the other side.
Yeah, so this pallet contains all the operations. So every run, we get finished handles off of it. I'm actually gonna pull it out right now so we can check it out.
Blow me. Oh, God, that's hot.
Well, it started plastic.
Oh, yeah. Oh, that's satisfying how that just kind of fits
Yeah.
right on there, huh? So this stock,
Yes,
Went
so
in
it loads
here.
up right here. So like I can take these out real quick. We'll pull one out. Thank you.
thank you very much.
So like this one, that comes out. So that is now a finished op one. We would inspect it for proper Zen pin fitment, check for finishes, things of that nature. And these are the Prisma V2s, but same exact process for the Prismas, same fixture, everything, just different program. And then we'll go ahead and pull off the op 2 handle.
Oh, that's
so-
held on differently. Oh, you're holding it on from the channel.
From the channel, yeah. So
That's clever.
this will end up getting flipped in like that.
Yep.
And then we have full access to the top side. We like to inspect all of our parts.
Of course.
It'll go into its position, the clamp goes in. Now it's clamped up, ready for op 2 to run, or the whole program really.
So essentially, this fitment here, you've just made it really precise.
Yes.
So that it auto locates itself.
Yeah, you have to push it up against this wall here and up there, but it locates up very nicely.
That's awesome.
Yes, and then the raw stock for op 1 would then go into the fixture like that.
You're so fast with it too. I love that.
Yeah, I mean, we've done this a lot of times.
That's hot.
This pallet would also run the SlifTs. Yeah, so we could do SlifTs and Prismas, Prisma V2s, all on the same pallet because they have the same handle profile. And so yeah, these are the finished handles.
Do you mind if I see it?
Yeah,
Oh.
from here they would be lightly tumbled and then they'd go off to anodize.
Look at that.
Yeah, so this machine, it does all of our stock prep. So it preps all of our titanium handle stock. It also right now does all of our blade rough profiling.
Gotcha.
So it'll take those rectangles. These will get turned into a blade blank, which I can show you on the next machine. Yeah, so it's a very multi-purpose machine for us right now, but its primary focus is to make sure the other machines run and give us Prisma handles and Prisma blades.
Awesome. Okay, do you want to move on? Because I'm noticing there's not really any titanium over here.
Right, yeah, this doesn't do any titanium production anymore.
Gotcha. Is
Yep.
that this guy over here?
Yes, a lot of it is on this machine over here. One thing about the way we do production is all of our machines are pretty product based. So like this machine only runs serifs and opuses and all of the parts that are within those products, which means the handles, the weights, the blades. That machine takes the prismas, so that means the handles and the blades.
Yep.
And then our final machine that we'll check out later is the one that runs the SlifTs, which is also the handles and the blades.
So what is the reason that you would run single products on a machine as compared to at Squid Industries? I remember, I think they had a bit more of a parts-based mentality. So they could run just this kind of handle on this machine for a period of time until they build stock and then switch from there.
Yes.
So what's your mentality in running an entire product on a single machine?
Right, so we focus heavily on process reliability.
Gotcha.
So I know every morning when I come in that we have 3 finished serifs, 3 handle sets, 3 finished blades, we have finished prismas, and we have finished SlifTs. So every morning we have finished parts and we know that they're good. Whereas if you do more of a batch flow, which is a little bit more efficient, it can be more efficient. But if you have one small issue on the setup of that part in that machine for that batch of parts, then that entire batch is now scrapped. Whereas something on this, if we have an issue on a part in assembly, we can go right over here the same day, figure out what's wrong with it, fix it, and then by the next day, we have good knives again. So our scrap rates are very low because of that. Process reliability is a lot of things, but it is knowing that you're gonna get good parts, hopefully all the time or very close to all the time, but also that the tools that are making those parts in the machine, you know how long they're gonna last. And it's a very proven, reliable process where there's no human error involved.
Got it. So it's not just the actual reliability in terms of having a finished part done.
Right.
But it's also the reliability of the machine itself. It's the reliability of the parts that are making the part.
Yes.
Where are we starting? Because I see a lot of different things happening.
Yeah, so the flow through a day actually starts out with the hardened steel blades and the weights. They'll start out as just a blank like this. So this is heat treated and surface ground, but you can see it has the tabs on it. The profile is oversized. Zen pin geometry is machined, the whole profile of the blade, because that's one of the most accurate parts on the blade, one of the more important sections to make sure that your handle gaps are accurate and good. Yeah, the Zen pin locations relative to the bushing holes is like the most critical part on a blade in terms of accuracy.
Oh yeah, well, because that's going to establish your entire open, your handle gap, how well it works when closed, whether or not it's slapped.
Yep, so that's the primary focus that happens on this specific operation on this pallet. And then from there, it'll also do the swedge since we're there. After that, it'll get taken off and we will pop out that bushing.
Oh, so you actually put a bushing?
Yeah, we use bushings to locate our blades because...
Oh, that makes sense. Yeah, why not?
Yeah, why not, right? So then they'll get flipped over and they will go onto this side. And you can see there's no screws in this.
Yeah.
There's no play in that. It's completely located there.
Wow. Wait, do you mind?
Yeah, move it, try.
Oh. Wow, that's like it's like part of the material and you didn't... Oh my God, can't. Oh, there it goes.
There it goes.
So can I just put it down on that?
Yeah, so you just want to line up the 3 holes and just kind of push down.
Okay.
So I usually start with the front tab, just kind of get that one lined up a little bit. And then line up the bottom too, and it pushes right down.
And that is rock solid.
So that is perfectly located where it's supposed to be relative to the program now.
Wow, and then I assume you just screw that in and then...
Do some screws, and all that's happening on this side is we're just doing the second swedge. I should stress, these are machined in the hardened state. These are about 60 Rockwell, which is very, very hard.
That's hot.
Usually the process for machining hardened steels like that is to grind them, not machine them.
Does that add any problematic elements to trying to make these blades?
Oh, absolutely. That makes process reliability so much more difficult because it's really hard and it's really hard on your tools. You need very specific tooling, very expensive specific tooling, like these over here. This is what actually roughs away a lot of the material for the profiles. This is a hard mill specific end mill, and one of these is $90.
That is $90?
And this is a consumable that'll last a few days at best.
What?
Yes, so I buy 20 to 30 at a time. And I do that several times a month.
Oh my God. How large of a part of the process is this singular bit?
Cuts off the tab here. It ends up cutting this tab off as well eventually. Okay. It roughs all the material around the profile. It's a very integral part.
I had no idea those were that expensive.
So this is what's called carbide, which is next up to diamond in terms of hardness.
Wow, that's wild.
Yes.
A $90 consumable.
Yeah, and we have other tools that are more expensive than this that are also all of the end mills are consumables. From there, we actually move on to handles, because while this is running, we can load up the handle pallet.
Gotcha.
And then when this one runs, we get to pull these off, load up the bevel pallet, which is the night run. This is like a 12-hour cycle time just here.
Oh my God.
Just for the blade bevel.
For 6 blades.
Yeah.
Does that finish all 6 blades?
Just the bevels.
Oh my God. But that's only one side of the bevels.
Right.
In 12 hours.
If you think about it though, it's still 6 bevels, so it's kind of like getting 3 blades. Like,
But it looks like you could get 6 blades off of this in 12 hours, but you could only get 3 is what you're
yeah,
telling
because, well, we can only hit one side of the blade at a time.
me. Oh my God.
So while this runs, we load up the handle palette.
Got it.
And so this is specifically the palette for opuses. Right now, the serif handle palette is running behind us.
Oh, okay, so we got
Yep.
serifs in there, opus is right here.
Exactly, yep.
So I see we've got the clamps here, but there's no
Yes.
clamps on these parts.
Right. Yeah, so these clamps are really great. They have really, really good hold force for all the roughing on op 1.
Right.
However, we end up with almost nothing to grab onto here. And so anyone with an opus or an original serif will notice that there are 3 threaded holes in their handles.
Oh,
Which is
I
right
did
here.
notice
Yes,
that.
2
There's the
and
one
3.
there, and there.
Yes.
I wondered what that was for, because
Yes.
I thought maybe that was for some feature that just never happened.
Nope. Yeah, no, so funny enough, this threaded hole is used for those little nylon set screws that
Right.
absorb weight rattle. Their purpose is to let us bolt it to this subplate, which will then locate on pins and then get bolted through those 5 holes. 1, 2, 3, 4, 5. And now they are part of the fixture, and I have access to all the sides we need to machine them.
Wow, that is wild.
Would you like to carry one?
Sure, if you don't mind. Oh my God, that's a chunky boy right there. I'm just gonna let it.
So then, yeah, while this is running, we can swap over the blades from this palette, and they can go up onto the bevel palette. And this is our night run. This runs at night, unattended, because it's a very long process.
Got it.
So these start out just as the finished blades right here. So this is
So
just
it's literally just
finished
the-
profiled. This would have the wedge on it if it were done, and then it would go up onto this position right here, which is our op 1. It's just flat.
Okay.
This will go here, and there's clamps also that clamp the spine
Okay.
for the most rigidity possible.
Got it.
And it would put a bevel on it on the first side. So there's a bevel there. It would get flipped over. We need to do the other side of the bevel. But now there's material missing here. It's not supported anymore.
Yeah.
And so this would go, it would mate up with that. And that supports the bevel from all the cutting forces.
That's satisfying. All right, so this is a really complex process that you've got going on here. You've got the blades happening. This goes in, you get finished handles off of here, and then you get finished blades off of here.
Yes.
Is this all something that you have to keep track of? Like, is this something you're doing all of this?
No, so I'd love to give credit to Jacob. He is our main machinist now. He's the one that is loading all the pallets, keeping all these machines running, and he's pretty much directly in charge of keeping all of the machines you see here running production.
I got to meet Jacob earlier, and he was a fantastic guy.
He
This is I didn't know that he was the one really in the depths here.
Yes, yeah, he's been doing a wonderful job.
So you started very raw yourself
Oh yes.
in a garage?
Yes, in my garage, in half of a 2-car garage. Yes.
Oh my God. So you were really small yourself doing this thing originally.
Yes.
How has that been then, moving up and having people to help you like Jacob?
It's been wild. It's been crazy to think that I've even gotten here already. I mean, hell, even a year ago, it was me with these 2 machines and basically just me. So I was doing all of this on top of the assembly and social media side, like, and everything. So ever since having Jacob and then getting William now as well, our assembly tech, it's been a massive help. We have a much cleaner process flow. We get parts, more often because the machines are actually running all the time.
Yeah.
Yeah, it's been great. They are as much machine-wise as I am now.
All right, well, we're finished with these handles, but I know there's another machine over there. What does that one do?
So that is our newest machine that runs our SlifTs.
All right, I want to take a look. Can we do that?
Let's do it.
This machine is pretty.
Yes, this is our newest machine, our most capable machine, and I do love everything about it.
I like the blue.
Let me smash.
I like the blue.
The company is Brother, like the printer company.
Like the 3D printer company?
No, like the office printers. You know Brother, the office printers? They make CNC mills so they could make their printers better. And so then they started selling their machines. Yeah, this is a Brother printer, but
It's
machine
just a lot
edition.
larger, yeah.
Exactly. So it's taking what's called the keyway cutter, one of these.
Oh.
And so this is what's doing the channel on both the SlifTs and the Prismas.
So this is cutting in, like, straight
It's cutting
into
in
the
sideways.
side.
Yeah, so I have a handle over there if you want to grab one.
Oh, yeah.
In order to keep it to just be 2 operations, less times you have to take out the fixture, put it back in.
Yeah.
we're using a keyway cutter.
And that's literally just cutting out.
Yeah, so it's held up in the fixture just like that. It finishes up the profile and the faces and everything, and then this keyway cutter comes in and just... This is about a $189 tool.
Oh my God.
Yeah.
That's more than double the last tool.
It is, yes. This is the single most expensive individual cutting tool we have here.
And this is just as expendable as the previous?
Yes, so yeah, we'll get like 40 handle sets out of one of these right now.
Okay, that's pretty
It's
good.
pretty good.
That's something 80 individual handles?
Yeah, can I blow your mind for a second?
Yes.
So all of these tools need to be held in a tool holder, right?
Uh-huh.
Each tool holder in these machines is about 250 bucks each. And this one has 28 of them alone.
Oh my God. Is that a one-time purchase?
Yes, they are. They are.
Oh, thank God.
But like, you know, this holds
Wow.
our tools and then interfaces with the spindle.
You know, I haven't thought about it before because we're talking about how accurate everything here is and how
Yes.
accurate all of the
Right.
blades and the products themselves are.
Yes.
That doesn't even account for the fact that everything here
Yep.
has to be so accurate.
Oh, yeah.
So that the machine itself can be
Yep.
so accurate.
Yep.
So that all these little freaking numbers on this screen
Oh, yes.
are exactly what this tool is doing.
Yeah. The tolerances on that little hunk of metal you're holding in your hand are significantly tighter than anything we do here because they have to be. So it's filled with hydraulic fluid, and there's a piston in there that you tighten, and that actually squeezes straight up metal and puts pressure on it, which makes the metal contract and holds the tool. Yeah, it's super cool. I can nerd out for hours on
I was about to say, we came over here to talk about the SlifT, and now we're just nerding out about this beautiful machine.
Yeah, but ever since I brought the SlifTs back, specifically with the new smooth bevels, these have definitely done a number on my mental health.
Are these ground?
No, these are machined in this machine. And these are also hardened steel. This is 60 Rockwell S35BN.
These are machined.
These are machined, yes.
There's no, this looks like a hand ground piece.
Right.
Like I genuinely can't see the line.
Yes.
Normally on any other blade that I've seen,
Right.
you can tell when it's been machined because there are the lines.
As smooth as they are, funny enough, I'm still not happy with the finish. Because you can see, you know, there's gray up here versus down here is shinier. You know, each one is a little bit different.
Yes.
At the end of the day, that doesn't matter at all because they will get tumbled and it'll just make it a perfectly smooth tumbled surface and it'll do it really quick too. But just the fact that they are uneven still makes me a sad boy. But I can tell you that just the bevel section, like just the bevels, the finish passes for the bevels on this program, it's 7.5 million lines of code.
I'm sorry. The thing that you give the machine to do this.
Yeah, so the programs come in their standard text file. It's just, you can open it up in WordPad if you wanted to. That's what our software generates, and that's what this machine reads. That text file is 200 megabytes in size.
What? The text file?
Yes.
Yeah. 7.5 million lines of code.
And that code consists primarily of just XYZ positional commands.
Oh my God, is that what we're seeing? So this is the code, and there's, for that, 7.5 million.
Yeah, so like you can see right now, we're on line 12,034, and that program has just started, basically.
Wow,
That's the handle program too, funny enough.
Do you know how many lines of code are in the handles?
I do not. It's only a few megabytes in size, though.
So not several hundred megabytes.
Correct, yes.
God.
It's like on the Opus blades, we machine the tabs off.
Yeah.
But on these ones, because the tip is so pointy, I actually like to snap the tabs off because it leaves a little bit of it behind, and that keeps the tip protected from tumble from getting rounded over.
You know, I really love the look of the blade on my Seraph, but this might just top it. This is a really beautiful blade.
Thank you. I guess the thing I take the most pride in is our machining.
You are Machinewise,
right? Yeah.
All right, so I guess let's go take a look at the tumbling process?
Yeah, let's do it. So yes, this is our tumbling area.
Okay.
It's a very small, loud corner of the shop.
That's I remember the one that we saw at Squid Industries was basically like a big washer-dryer combo unit. This is a little bit more modest. There you go.
Yeah.
It's just two buckets.
It's this, we can run it with the divider, no divider. We have the divider in right now. And it literally just vibrates with a tumbling liquid, and this is just ceramic media. It's like fancy rocks.
A little Hershey kiss.
Yeah. Now, let me check. Let me see if it's actually done.
QC it for me.
Yeah. that's done.
Oh yeah, there's a bit of a like acidic like twang.
Yeah.
Gotcha.
Yep. As much as a lot of people really like the machine finish, the shiny finish, there's a lot of hard edges that come from machining.
Got it.
Even, you know, we can deburr those edges with chamfers, but then you have more sharp edges where those chamfers are, right?
That makes sense.
And so my primary goal with the tumbler is to both hide any machine marks. You know, we go for a really good finish, but you know that you can clearly see that there's a, you know, there's tool marks.
There is a bit of a mark.
These are the same part, just one is tumbled, one is not.
Oh wow, there's a substantial difference in the rounding,
which makes it feel much more comfortable in your hand.
Wow.
But also it gives you a very nice uniform finish. There's no more machine marks on it. Same thing back here.
Those sharp edges, you can feel pretty immediately that something is up.
Like it looks like a good part, but you hold it and it just goes, you're just like,
that's raw.
Nothing is, it's not finished yet.
But this one, like this just looks like a handle that you just gave me off of a finished.
Yeah, exactly. Like, that feels like how a finished handle should feel. And for those who do like the more shiny machine finish, we do have a laser machine now, so we can laser polish the tumble finish off, but still maintain all of the nice soft edges.
So everything goes into Mr. Deburr over here.
Yes, Mr. Deburr. And so for blades in particular, same kind of thing. It rounds over all the sharp edges, makes it feel a lot more finished, and it also gives a really nice stone wash look on the flats. Yeah, so now the parts are tumbled, they are finished. They are ready to go over to the finishing area, which is up front again, where they can be anodized if there's gonna be any anodized ones. The blades will need to be laser engraved for the serials and the logos, and then it's off to assembly.
Wow, okay, cool. Now, I'm looking in this direction, and I know that we came in and that's where the assembly area is.
Yes.
But I'm noticing, when my gaze drifts to the right here, that there is a thing that says CNC on it, but it is not being used and is much smaller.
Exactly.
What is that?
So this was the very first machine that I started with.
This is the
very first mill. Do you remember having the Time Aran and Marin Light in that video you did?
Yeah.
This machine made those. This also made all of the 50s, all of the Delta 4s. This is what I started on. So the Marin prototype was made on this.
Obviously, this is a much smaller operation.
It is.
This is what was in your garage.
Yeah, it was me and this machine in a garage. I mean, from a just like core what it is the same machine as any of my other mills in here. It is a standard 3-axis mill, and it does all the same motions that these do, just on a lesser scale. But the biggest thing that it doesn't have, there are two things. One, there's no enclosure. So managing
obviously
chips,
just open.
literally when it was running, cutting material, it would spit a stream of chips out.
Oh God.
And I would have to put up a piece of cardboard to block that stream of chips from burning the paint on my girlfriend's car.
Oh my God.
And so that was one thing it didn't have, which also meant that I couldn't have flood cooling, which is all of that liquid that you see in the
the machines are spraying a bunch of coolant.
And that serves a lot of that serves a lot of purposes. Primarily, it serves to help evacuate the chips away from the part.
Sure.
But it also keeps all the temperatures cool. It lubricates the cut, and it keeps the cool tool. The cool tool.
The cool tool.
I'm a cool tool.
You're the coolest tool, Brandon.
You are the coolest tool, Brandon.
Yeah. The other thing, the most important thing that this machine doesn't have is a tool changer. You know, I can't just use one single tool to make a part. All these machines are able to change the tools automatically, and they have a library inside of them of 15 to 30 tools.
Yeah, it was especially obvious on the Brother right here. It has a big drum.
Big wheel, and it spins and slams up, slams down, changes tools.
This doesn't have that. So what does that mean in terms of actually processing the part?
I'm the tool changer. So I would have all my tools lined up nicely in here when I was using it. Now it is a mess. And I would have to grab my wrench, which is right here. And I'd be sitting on a little stool waiting for it to finish in my hot garage. And I would get up when it's finished every 5 minutes or so.
Oh my God.
Come over here. Unscrew the tool, pull it out, throw in a different tool, retighten it, and then press the green button again, basically.
Oh my good Lord. You were doing that every 5 minutes.
Yeah. I probably made at least 200 knives on this thing back in the day.
God.
Yeah, this single machine funded everything you see here, basically.
Wow. We've talked about this before. People believe that CNC is like, oh yeah, you just, plug in the USB, hit the go button, and you're off to the races. You literally, it's not even
right.
From this to that, it almost is. With this, you are there.
Yeah.
Changing the tool every
Yeah, sometimes I'd have 20 tools lined up in here that would be for one program too.
Oh my God, so 20 tool changes in one program.
Yeah, actually you can tell if you look at this thing, see how mushroomed over this is?
Oh my God.
That looked like a perfect square at the beginning. And that's just from me whacking it with a wrench over and over.
Oh my God, it's polished on top.
Yeah, I've never seen the top of it.
Let's move along.
Yes.
And assembly is next? Or
Yes,
is
assembly would be
something
next.
before
It would depend if a part will be anodized, then it'll get anodized before assembly.
that? Okay.
Yep.
I would love to look at your anodizing process.
Yeah, definitely. Let's check it out.
All right, so now we finally make our way to the front.
Yes, before we get to anodize and assembly, this is a step that happens a little bit earlier on, and it is probably one of the more important steps of the process, and this is our surface grinder. Basically, it takes our oversized thickness blades, and it brings them down to the final thickness, keeps them very accurately parallel, flat, and it's very accurate on the thickness. It's gonna hold 1/10,000th of an inch. I mean, without this surface grinder, we wouldn't have the tunes we do. We wouldn't even be able to make a balisong that doesn't have bind. This is the machine that keeps our tolerances in check.
I didn't realize that this was the one.
This is
keeping
literally
the tunes
half
together.
of my reputation.
Oh my God. Okay, so now we're moving on to anodization.
Yes,
That's this little area over here.
right here.
So I talked a bit before about how your process was somewhat more relatable to
Yes.
people than what was happening at Squid Industries, and I think this is my personal favorite example of that.
Yep.
Over here, your anodization process, you have a peanut butter pretzel container.
Yes, don't sleep on those. They're really good.
I love how janky this setup is because it reminds me of home
Right.
in a very real way, because
Yes.
this is literally what it looked like when I learned to anodize.
Oh yeah, no, this is clearly a very professional setup.
I mean, it is, in fact, literally a very professional setup.
Right? As far as I'm aware, and I haven't done a lot of research on it, but as far as I'm aware, there isn't really like a professional kit or setup or equipment for it. Even at a shop I used to work at, they're a 100-employee shop and they made jewelry and titanium, so they did a lot of anodizing. And their setups were not much different from this.
So what have you got going on here? What's the process to take a part
Yes.
that we just made and anodize it?
The first step in a good titanium anodize is make sure your parts are as clean as possible.
Got it.
I found these ultrasonics to work the best. We used to use the steam cleaner, and it still does have a really good purpose. We use it more for cleaning off like customer knives now when they come in kind of gunky. So we have our small ultrasonic, which is kind of like the rough clean. It gets all the like big particulates off. And then we have this much larger ultrasonic cleaner with a really aggressive solvent in it that gets all the grease off. It's literally cleaning with sound and
Wow.
solvent.
That's
Yep.
really cool.
Yeah.
From my experience anodizing,
Yes.
having a clean part is like the whole point.
That is what makes or breaks an anodize 9 times out of 10. So the first step from there is we want to make sure we wipe off any of the solvent and that. So we'll do it in just a distilled water, clean water rinse bath, just to rinse off any of the remaining solvent, anything else that could be on them. All metals end up building up an oxide layer almost immediately. And so even between the machining to the cleaning, even out of this bath into that one, it builds up an oxide layer.
Yeah.
So we want to etch away that oxide layer, expose fresh titanium. And this is specifically designed for titanium etching for anodize.
Gotcha. That makes sense because from what I remember, the thing that actually makes the color itself on the titanium is the oxide layer.
Correct.
Is that correct?
Yeah.
Okay.
And how thick that layer is affects how it refracts light off, which is the color.
Fine.
Yeah, you're just changing the thickness of that oxide layer by probably a few atoms at a time. So from there, out of etch, now it is nice, clean, exposed titanium ready for anodize. It'll go one more final time in the rinse water. So we don't want any of the etch liquid in our anobath for obvious reasons, right? Out of there and then into our actual anobath. This is where it gets anodized.
So you have your anodization happening. You have a nice little power supply here.
Power supply, yes.
That gives you a selectable voltage, and the voltage equals the color.
The higher the voltage, the thicker the layer gets, the different colors you get. The spectrum is in the correct order, and the voltages are going to be close, but every setup is a little bit different.
You have all of your anodization happening here.
Yes.
Now do we put the knife together?
Yes. All the parts are finished and ready for assembly.
Okay, so where does assembly happen?
Assembly happens directly behind me. So this is the assembly station. This is William, our head of assembly.
William, it's nice to meet you.
Hello, Will.
Cool. Do you mind if I hang out with William for a bit and figure out what's going on here?
Absolutely, I'll leave you two to it.
Awesome. Thank you, Dalen. So you are in charge of anodization and assembly and laser engraving as well?
Yeah.
So what is your process over here?
Well, first off, we go down here and grab 2 Prisma handles. We take it over here to press in pins. So you take a pin and you shove it in.
That's hot. Oh, so there's actually an area that like lets you set it in. So you're not trying to
No, we
force
used to
it
do
into a
that.
smaller hole.
By crushing the pin in, we close up the tolerances inside the channel.
Got it.
And by doing so, we have some issues at times. So by putting a little spacer in there, we no longer have issues. You take it about halfway in, right about there.
Got it.
Sweet. Now we take a blade. This is just a scrap blade from
Oh, so this
who
is
knows
just
what.
the middle thing to keep it from scratching?
Yep.
Got it. Can I go all the way?
Yep.
Cool.
Perfect.
Press the pins into the handles.
Yep.
Now what do we do?
We grab the blade. We have a whole little stack over here. Just grab any random one. Should all be the same. And we measure how thick the blade is.
So you're actually using a micrometer for every blade.
Yep. So our bushings have to be about 1/10, and that is really tight, surprisingly. Grab it. We're at 126.3, so 1/10 over, and we're about 2/10 right now.
Wow, so you're already relatively close. Huh?
Yeah. So we do a couple of passes.
So you're just doing a figure 8 onto what is essentially a sharpening block, huh?
Yep. Or every 4 passes, you want to rotate it. 1, 2, 3, 4, rotate, and then do 1, 2, 3, 4. If you don't do it, it creates a little divot in the very center. That wears down over time and gives us either bind or we have too much play or lots of bad things happen. Close.
Ooh, oh my God, it's exact.
And washers have to go on a very specific way.
And these washers are special. These aren't like the washers that other companies use.
No, these are stainless steel washers and they are better. They're harder. They maintain their tune longer.
Got it.
So you don't wear out the bushings and have to replace them. They have easier horizontal swing. They're smoother and they even polish themselves as they're used.
Oh, that's cool. Because I know, so I've talked about before how every time that you replace the washers, like every time that you basically tune your Balisong, you need to replace the washers.
Yeah,
This keeps you from having to do that.
exactly.
Okay, that's really nice. All right, so you just assembled that while you were explaining the washers to me. You got that done really quick.
It's just kind of muscle memory. You get used to it pretty fast.
That makes sense after you've been doing it so much. Oh, yeah.
Now we want them to be able to tune without lube.
Oh, right, this is fully dry. So you wait, all right, wait. You're going too quick here. Walk me through the pivot needle.
Sorry. We just
You
have a
are
little,
such a master at this.
we have a little pivot needle over here.
Yeah.
It's standard. It's slightly smaller than the diameter, inner
Got it.
diameter. So you just shove it through.
And that aligns everything in there, and then you literally just shove the pivot behind it.
Yep.
Beautiful.
It falls out. Boop. There you go. And tuned.
That was fast.
Yes, we're about averaging, on a good day, on normal things, about 3.5 minutes, 4 minutes a night, or on Prismas,
To be fully tuned.
to be fully tuned. Honestly, the longest part is actually screwing in the screws,
Yeah.
because there is no shortcut. There is no fast thing. There is no, you just have to sit here
And
and
screw it
screw.
in.
So yeah, we just sit here. Oh, hi.
Yeah.
Nice little conversation. And we're finished. Throw a little bit of lube in there. So now that we get the lube all the way in there, we do a tune test.
Oh, wow. So you're not just like kind of checking the play. You're really pushing.
Yeah, I'm pushing. And then we do a horizontal swing.
So why horizontal swing instead of just a normal vertical swing test?
So let's say it binds right here.
Yeah.
You can go through, but the momentum and the gravity will let it pass through and come back. Now, if it's bad bind, it will bind, right?
Sure.
But it will be very noticeable right here. Blade centering, very nice. You shake it, should be
Gotta
pretty
shake
hard.
it
And then you flip it for a minute,
So why flip it firm?
because it's fun.
Here we go.
See, now it's just completely bound a little bit. All you gotta do is shake it.
And work out that bind.
Yep. It takes half a second.
And that's a great example of why you do this initial check at the end of everything, just to make sure that it is exactly what we need it to be.
Exactly.
So what's the difference in the process then? We have a Prisma here. What's the difference between this and like a Seraph or an Opus?
The process overall is exactly the same.
Got it.
We have two different degree differences. We put weights in. And then we have Zen pins.
And the Zen pins and these are just floating.
Yep,
Yep.
floating.
So no press fitting, no nothing like
no
that.
press fitting. And you have a handle. From here, it's the exact same. The only difference is when tuning, you have to put in the bottom screw first. There's a lot of people that will have like their knives wanting tuned, and they never tighten the bottom screw.
What do we do now that you've finished it, you've checked the tolerances, you're happy with it? Do you need to check the finish or anything?
Yes, we do. We're looking for inconsistencies, little scratches, and little dings.
Got it.
There shouldn't be any scratches, and I am not seeing anything on this one.
Great. Okay, so is that passing me back to Dalen then?
Yeah.
Awesome. This is much more accessible to me. Like,
Yeah, definitely.
This is something I recognize as something that I've done before. Having the bench, sitting down and taking apart my knife and putting it back together. This feels much more relatable to me. So I appreciate you showing me the process. And do you mind if I bring that over to Dalen?
Sure thing. Here you go.
Awesome. Thank you so much, man. Appreciate you.
Sure thing.
All right, Dalen. So me and William got this Prisma here assembled and tuned up.
Yep.
What do we actually do to get it out the door now?
So from here, the last step is just to do the final QC on it. Every knife that we ship out, I personally go through, check the tune on, look for scratches, blemishes, anything like that.
Gotcha.
And that'll determine if it's a blem or if it's a good part or not.
Cool.
And then from there, it's just doing the QC card, and then it's ready to be boxed up and sent out. William also does this same process, and it won't be long, honestly, until he's just the one doing final QC.
Wow. Cool.
Yeah, no, it's incredible, right? And what I do for the tune checks is I'll check horizontal swing, both directions on both handles, and that'll just tell me if there's any resistance anywhere that could inhibit it from being, a good flipping knife. And then from there, I'll just look for any scratches or blems in the anodize, which I'm not seeing. The last thing I'll check is blade centering, which is looking pretty good. A little bit of a play test on it as well. Just the generic tune checking process. And then I always like to do the ice pick sound test. It really tells me. You can find out a lot about the tune just by doing the ice pick sound test, so we do this here all the time. So this is a good part ready to ship out. So from here, I would get the QC card going. This is one of the ones that you two are so kind to sign the cards on, so I'll go pull one of those out.
Yes.
Beauty incarnate.
Thank you.
Whoever did the process will fill these out. Oftentimes we are running a bit behind, so I take the liberty to fill them out myself if I have to.
Got it.
Yep. Oftentimes you will see cards with William's initials on it as well.
Cool.
And this is a good part, so it gets this little smiley face.
Yay.
Yep.
I love the smiley face.
I'll go ahead and grab.
Did you hear your funny bone?
Oh yeah. Damn right I did. And then a box. And then before it gets wrapped up, we need to put it into its actual final box. We like to have control over as many processes as possible, including packaging. There's nothing worse than having a ton of inventory ready to sell and we can't sell it because we don't have our boxes in time.
There's something nice about just having a custom solution like this.
Yes,
like,
exactly.
I genuinely just kind of love it. It feels like a sort of personal touch coming from you guys.
Yeah.
That just, I don't know, it just works.
Most, if not everyone, seems to legitimately enjoy them and think they're cool.
I really like
That
it.
makes me happy because I think they're really cool.
I agree.
Yep. So yeah, from here, like we have a spot that is perfectly shaped for the knife,
Oh, beautiful.
right? And then we have spots. So this is the same box for all of our products. So we have little holes up here where the nylon weight or nylon screws would go for the Opus and Serif. Spot for extra phosphor bronze washers. And then these are actually positions for the weights for the Opus and Serif. So then from here, I would put in 4 phosphor bronze washers. Throw it in.
How satisfying.
Right? Yep. Throw that on. QC card. And finally, a sticker.
Gotta have the sticker.
Gotta have the sticker,
So
right?
important.
And then it's a box burrito. And then tape. And we tape all sides of the box. That way they can't come apart during shipping.
That's out the door then, isn't it?
Yeah, that's ready to go.
One last thing, I think this might be a fun thing to end on actually.
course.
We didn't get to cover it in the production process because
Yep.
you don't actually do it in the production process.
Correct.
But sharpening the blades themselves.
Yeah, so sharpening on live blades is the absolute last step before it comes over here into a box. Usually we'll actually print the labels out beforehand.
So when it comes to that, I guess I'd like to go take a look at the sharpening station and just see
Yeah.
what that process is. But,
Absolutely.
You want to go sharpen, I guess?
Let's go make something sharp.
What do we need to make sharp then?
We need something to sharpen.
You guys are saying it wrong.
Sharp. Pin.
Take away one letter. You're almost there.
Shark.
No.
Harp.
No.
Shap. Okay.
Shap.
Shab. Oh, I have to shap.
Shap.
Shap it?
Shap it.
I have to shap it?
Not Shap.
He is not shap.
I ain't Shap.
Well,
You
right
don't know
now
your own memes. You don't know your own. You don't know our memes.
Are you from Boston? Got a shap in it?
Ooh.
So this is our sharpening station, our little sharpening table. So we decided on this machine after trying many different methods of sharpening, primarily because it has all of the angle controls and a jig on it, so you can get consistent angles and consistent edges every time. And the reason I wanted to go that route is because in the future, I would like to not be the only one sharpening. And it took me a very long time to learn how to sharpen freehand. And even to this day, I still have to do it like on a slack belt. I can't just freehand sharpen on a hard surface.
Got it.
Sharpening is the quickest step out of everything that'll take a good knife and make it a garbage knife.
Oh yeah, I guess it is a pretty lossy step.
Yes,
you mess it up here.
One slip, too much pressure on one side over half a second, and now your blade is just scrap. So you clamp up the blade. A little blade clamp has tape on the inside too, just to keep from scratching. Just in case.
Yeah, that makes sense.
Power on. Whoop.
Blade does kind of start calm.
Yeah, and we sharpen it about 26.5 degrees. And we do that primarily because these are balisongs and they're going to hit the floor.
That's a good point. The steeper your angle,
the sturdier it is behind the edge, right?
Yeah. If you go for a really acute angle, you're going to have a very easy scatter.
Yeah, exactly. And like, we do make very sharp edges. If you go for a finer angle, then it's even sharper and it's just a laser and it's scary.
Yeah.
That said, these edges will still shave. One final pass on this side. Now we got to get the tip. And that actually came out nice and even.
Wow.
But it does take a bit of doing many of them.
Yeah.
To get the feel for it.
It feels like it's got a bit of finesse there.
Yes. People who are professional sharpeners will usually call the burr that's formed up on that edge the foil. So we're actually grinding the material away until it creates like a foil, basically, on that edge.
Got it.
So what we have to do from here is we have to strop it.
Oh, okay.
With it's literally a leather belt with a little bit of polishing compound on it.
I see.
And we run that away from the edge, and that will fold the material over. Then we do the other side, it'll fold it over. You do that a few times, and it'll literally just fall off. And then you have a really, really sharp edge. It'll also kind of polish the edge up a bit.
Make it a little pretty.
Yeah, it'll make it a bit shinier.
I love that.
And from here, it's just a matter of cleaning it off, checking it out, making sure it's all even. It's looking pretty good. Bit of shine to it as well.
Beautiful. Oh, like butter.
Yeah.
Like butter. Well, dude, it's been amazing taking a tour of your facility and seeing something like this go from a literal hunk of metal at the beginning of the day into a finished product made of these individual parts. That's really awesome, dude. This has been such an interesting experience, getting to see everything that you've put together and the way that it turns into such a wonderful final product. Also, the tune on this thing is just insane.
Is it?
Yeah, I mean, give that a check real quick.
Oh yeah, William does a phenomenal job.
Wow. But yeah, so thank you, Dalen.
Yes.
Thank you to the rest of your team as well for being very awesome and having us here.
Definitely, thank you for coming out.
I think we have a video upcoming where we're gonna take a look at your entire product line. For now, that has been a look at the entire machining process, assembly process, finishing process, every process here at Machinewise to go from a piece of metal to a finished balisong. So thank you so much. And also thank you to our wonderful patrons who include Dalen himself. You guys allow us to do videos like these, and you guys really do support the channel, even when we are in times of hardship. So thank you so much. If you want to become a patron, it is only $3 a month, and you get access to the community Discord server, as well as many videos like these days in advance of the public. You can comment on those videos before anyone else has the chance to, and then when people on YouTube later are like, why is there a comment from 3 days ago? Now you know. So yeah, thank you once again, Dalen.
Absolutely.
And until next time, I guess we'll be seeing you.
Goodbye.
Bye, everybody. Bye.
Bye. Now, if you'll excuse me.
Oh, wait, no, we need that. No, Brandon, get back here, Brandon. Brandon.